For centuries, sailors crossed a seemingly endless ocean. Familiar were the surface waves that lapped against their wooden ships. But what lay beneath the waves was unknown and sometimes feared. Stories were told of mysterious beasts lurking within the ocean depths, waiting to rise up and shatter unsuspecting ships. The ocean covers more than 70% of the Earth. It's a feature that defines our planet, yet only about 5% of the deep ocean has been seen by human eyes. Advances in technology are now allowing all of us to explore this inner space that wraps our blue planet. Exploring the deep ocean is extremely challenging. In the beginning, we used diving gear, heavy helmets, bulky hoses, and cast iron belts to explore shallow waters and test human limits. Then came human-occupied submersibles that can withstand the crushing pressure of the deep ocean. They provide scientists a front-row seat to directly observe ocean life. Today, research and exploration vessels, including the National Oceanic and Atmospheric Administration ship Okeanos Explorer and the Ocean Exploration Trust exploration vessel Nautilus, as well as other ships, carry crew, scientists, and technologies across the global ocean. We can even use tools in outer space to understand Earth's inner space. This map of the Earth was created using large-scale satellite data. It reveals the irregularities of the seafloor and hints at amazing landscapes hidden beneath the waves. But the resolution of this map is coarse. To see what the ocean floor really looks like, a more precise system is needed. Ship-based multi-beam sonar provides much more accurate detail on ocean depth. Multi-beam sonar works like this. Acoustic transmitters mounted on the hull of the ship send out a fan of underwater sounds called pings. These pings travel through the water column, bounce off features in the water column and/or the seafloor, and return to the ship. The time it takes for the pings to travel round trip is translated into water depth. Detailed, high-resolution, color-coded 3D maps of the seafloor, such as that shown here, are generated. The colors indicate water depth. Warm colors, red, orange, and yellow, represent shallower water. As the waters deepen, the colors shift to dark blue and purple. The depth and shapes of the underwater terrain is referred to as bathymetry. An underwater terrain more varied and dramatic than that on land has been revealed. Majestic seamounts rise up from the ocean floor, some linked together to make vast underwater mountain chains. Huge canyons and trenches, some deeper than the Grand Canyon, carve a jagged path into the ocean bottom. Sonar pings bounce off bubbles escaping from cracks in the seafloor. These bubble detections have led to major discoveries of deep-sea vents and seeps. Through the lens of multi-beam sonar, we've even had our first look at previously undiscovered shipwrecks. Multi-beam bathymetric maps allow scientists to pinpoint areas of interest. Remotely operated vehicles, or ROVs for short, are deployed to further explore these deep ocean targets. ROVs are highly maneuverable underwater robots. They're connected to the main vessel by a flexible stainless steel tether and are driven by pilots on board the ship. There's no limit to how long an ROV can remain at depth. This ability to provide around-the-clock underwater observation has transformed ocean exploration. An ROV's powerful lights illuminate the dark, deep ocean environment, hotspots of biodiversity that can be protected as national monuments and marine sanctuaries. Vivid imagery of fascinating creatures excite, captivate, and sometimes puzzle observers on the other end of the camera feed.
Wow.
Wow.
Look at that. Right.
Oh man, this is a gorgeous animal.
Wow, that is just brilliant imagery.
Whoa.
What is
It's one of the-
that? It's ginormous.
What is that?
This is fantastic video, though.
It is, isn't it?
Indeed.
An unexplored area down here, so an unexplored and hard to reach area here at 1000.
I think it's an octopus. Good grief. I have never, ever seen that one.
Excellent.
What really makes ocean exploration work is the people. One of the latest advances, Telepresence, allows anyone, anywhere in the world to jump into an expedition at any time. Telepresence provides a critical real-time link between people on land and those at sea. Data and video feeds from ROVs at depth are transmitted to a satellite and then streamed in real time through the internet. Scientists, resource managers, and the general public can tune in and become active members of the expedition. Amazing discoveries are not just limited to people on board the ship.
0.3
Is
for
this
50 meters.
indeed? I wonder.
Because of Telepresence, even you can be part of ocean exploration as it happens. From your computer, from your tablet, even from your cell phone.
You can tell we're stumped, so that's exciting.
How deep will we go? Will you be there when the next discovery happens?